today will present to you about our topic is breast cancer risk prediction. Okay, first of all, what is breast cancer? Breast cancer is an uncontrolled and abnormal growth of breast cell. Breast cancer starts when the cell in the breast grows out of control and form a tumor that can only be seen through an X-ray that we call mammogram screening, or it can be also felt as alarm. So when we talk about cancer, it is a cancerous tumor, and there's it divided into two: benign and malignant tumor. So what is the difference? Malignant tumor is a cancerous tumor that spread throughout the body, but benign, it's a non-cancerous and unable to spread throughout the body. And benign tumor can only be serious if it press the main artery or the primary nerve or the compressed brain. In Latin, malignant means badly born. It has the ability to multiply the cancerous cell and spread throughout every part of the body, and it has the ability to invade surrounding tissues. Breast cancer is the most commonly diagnosed cancer in women and the number 2 most dangerous and second leading cause of cancer deaths among women after the skin cancer. And 1 in 8 women will diagnosed with breast cancer in their lifetime. Although breast cancer in men is rare, but it's possible to happen to them. And estimated 2,470 men will be diagnosed with breast cancer, and approximately 460 will die each year.
So now we proceed with objective. In this project we get 3 objectives. The first one is to learn how to apply KNN machine algorithm into our dataset, because in this project we choose KNN as our machine learning classifier. The next one is to create a classifier model that provides a high level of accuracy and with low rate of false negative as our result. The last one is to be able to predict the existence of breast cancer from gathered blood analysis as our conclusion.
Assalamualaikum, my name is Sakina, and we're going to continue our presentation about literature review, which is the paper that we studied for our project. The first one is a comparative study of breast cancer diagnosis using supervised machine learning techniques. It is stated in the paper that the prognosis of cancer is important for the survival of patients of breast cancer. Therefore, the machine learning techniques and also the technology actually improve the accuracy of prediction and also the classification of cancer. In this paper, they apply a few machine learning techniques to the datasets, the same dataset that we use in our project, the Wisconsin dataset. They apply a few machine learning and find out that multi-layer perceptron is one of the best machine learning that can be applied to the dataset. The second paper that we studied for our group project is iterative weighted KNN for constructing missing feature values in Wisconsin breast cancer datasets. So this paper proposed an approach to extract missing feature values using the nearest neighbor and also the distance matrix. So here they use the KNN algorithm to propagate the predictive features in the datasets. So actually this paper is a part of a research which aim to automating the process of diagnosing the cancer. So future works, actually the paper is important in the process of mining, before the mining process of the datasets. And another paper that we studied for our project is analysis of efficiency of classification and prediction algorithm named Bayes for breast cancer dataset. Data mining techniques are used to provide the analysis and also the classification algorithm. So the algorithm used here are Bayes classification algorithm and also the prediction algorithm. The algorithm actually are used to classify if the tumor is benign or malignant. So the data used in this algorithm is taken also from the same data set that we use in our project. datasets are used. In this case, datasets are used to find the success rate, also the error rate. That's all from me. Thank you.
This dataset we used was created by Dr. William H. Walbert, a physician at University Wisconsin Hospital at Madison, Wisconsin, USA. To create the dataset, Dr. Walbert used fluid samples taken from patients with solid breast masses and an easy-to-use graphical compute program called XCyte, which is capable to program the analysis of cytological features based on a digital scan. The program used a curve-fitting algorithm as shown in the figure. To compute the features from each one of the cells in the sample, then it calculates the mean value, extreme value, and standard error of each of the features for the image. The attributes used in the datasets are ID number, diagnosis, M for malignant, and B for benign, radius, mean distance from the center to points of the perimeter, texture, perimeter, area, smoothness, local variation in radius length, compactness using the formula perimeter square divided by area and minus by 1. Concavity, the severity of concave portions of the contour, concave points, the number of concave properties of the contours, and symmetry along with the fractal dimension by using the formula coastline approximation minus 1.
And next, we continue with the methodology. For this experiment, we first did the data collection, and then we did the data exploration and preparation. After that, we did the data transformation. Next, we proceed with the training and testing. Then we proceed with the model training. And lastly, we did the model performance evaluation.
So basically, why we use ScanN? Because it is a simple algorithm and also it has high accuracy than other machine learning algorithm for this dataset. And also we want to classify for the tumor for each individual, whether it's malignant or benign, based on its k nearest neighbor. So based on our model, this is the result. So the first one, the upper right one, it is a true negative, where the model predict it as benign and it is benign. The below one is the false negative, where the model predict it as benign but it is malignant. So it is dangerous because the patient could think that they are healthy, but in reality they have the cancer. The next one is the upper left one, where it's predicted as malignant but it's benign, where it is dangerous but it is less dangerous than before this, because the patient may think that they have the cancer but they actually not. And the last one is the bottom left one, where it predicts as it's malignant and it is malignant.
As a conclusion, we know how to apply the KNN machine learning algorithm into the dataset. We also created a classifier model that has a high level of accuracy with a minimum rate of false negative. Finally, we are also able to predict the existence of breast cancer tumor from the collected blood analysis. That's all. Thank you from us.